Hello everyone, it's September 3rd. Let's get into it. Walking robot simulation. I just learned that I need to write some C++ code. I just have to laugh. I haven't touched C++ for many years. A robot on infinite xy plane starts at point 0, 0. Facing north. Robot can receive a sequence of these three possible types of commands. -2 is turn left 90 degrees, -1 is turn right 90 degrees, 1 to 9 move forward k units, 1 unit at a time. Some of the grid squares are obstacles. The ith obstacle is at grid point obstacle I. If the robot runs into an obstacle, then it will instead stay in its current location and then move on to the next command. Return the maximum Euclidean distance that the robot ever gets from the origin squared. If the distance is 5, return 25. Note, north means plus y direction, east means plus x direction. South and west, there can be obstacle in 0, 0. There can be obstacle in 0, 0. All right, let's say we start as 0, 0, right? So we start, this is 0, 0, and we know obstacle, so we start facing north. So we go 4. So 1, 2, 3, 4. And then -1 is turn right 90 degrees. Now we're facing this way. And 3, 1, 2, 3, 25. Okay, so now we have again 0, 0. We go and 2, 4 is a 1, 2, 0, 1, 2, 1, 2, 3, 4. Okay, so we go 4 first. So 1, 2, 3, 4. -1 facing this way. We go 4, 1, 2, then we stop, right? 3, 4, we stop. Now we'll wait for the next command is -2, turn left. So from this direction, turn left, so we're facing north again, and then we do 4, 1, 2, 3, 4. Okay, so this is actually 8, and the math, so basically 8 and then it's 2, so 4 plus 64, 68. Holy crap, 65. Huh? Move 4 units at 0, 4. Turn right. Move east 1 unit and get blocked by the obstacle. Oh, this is obstacle. This is obstacle. So we cannot reach here. So we reach here. We cannot go. So, then we go 8. Okay, so 65. Gotcha. Okay, so basically just simulated, right? What was simulated? We just need to know -1 and a -2, how we do it. Like in the current direction. So the current direction can always be go like 1, 0, 0, 1, -1, 0, and 0, -1, right? And we start with 1, 0, going north. This is going down. This is going, actually no. This is going east, going west, going south. So when we have turn right 90 degrees, right? Turn right 90 degrees, which means this, so we have 1, 0 should turn into 0 minus 1, right? And then 0 minus 1 will turn into minus 1, 0, and then minus 1, 0 will turn into 0, 1, and then 0, 1 will turn into 1, 0. So what is the rule here? The rule is 1 becomes 0. That's 1 becomes 0, 0 becomes minus 1, minus 1 becomes 0, 0 becomes 1. How do you minus 1? Minus 1. But if it's already minus 1, it how do we summarize the rule? Do 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 do. I mean, we can just do a bunch of if and else, but if I can find a way, this is turn right, right? This is turn right. If I can find a way to represent this, well, for one, if it's at 1, it becomes 0. If it's a negative 1, it becomes 0, right? That is easy because basically you just change, doesn't matter, right? If originally is 1 becomes 0, minus 1 is 0, minus 1 is 0, 1 is 0. So that is easy to do. Now the difficult part is 0. So 0 become minus 1. Sorry, 0 will turn into minus 1. Minus 1 will turn into 0. And here 0 turn into 1. And then 1 turn into 0. So it depends on, so like when you are 0, which way do you go? One, actually, no, we already discussed this. So we only need to so yeah, this is discussed. 0 turn into minus 1. Okay, this is 1. And this is 0 turning into 1. Because we know 1 will go into 0. That's not a issue. It's just in these two situations, 0 turns to minus 1. 0 turns to minus 1. Ugh. In these two situations, 0 turns to 1. And 0 turns to 1. So I'm thinking, maybe we, oh my god. Do we just, I mean, I don't, how do you manage this? Well, basically 0 turns to 1, which is you know when it's going to be a negative 1. It's a negative 1 if that's a 1. Okay, so if we go 0 minus 1, so if we go north and south, right? If we go north and south, then we need to flip the yeah, I don't know. It feels unnecessary, right? Does Java has switch? Can we do? Damn. Oh, I probably can do. What if I have these in an array? We can say 0. We can say north is 0, right? That doesn't matter which one is which. If we just follow this, right? East is 0, north is 1, west is 2, south is 3. And then whenever it's something, I get something else. Huh? Yeah, look at this. If I turn right, it can be south. South turn right is gonna be west. West turn right, yeah. It just circles through. All I need to do is, I see. I see what I can do there. Okay, so that solved. So then what we need to do is in that direction, we check because we need to see if the obstacle will be encountered. But the obstacles, there can be many obstacles, right? There can be many obstacles. Then how do we ensure that you are not hitting the obstacle? Oh, that's a good question. We need to ensure we're not hitting the obstacle. So we need to know the obstacle. Oof. I know my current position, x and y, row and column, right? X and y. And obstacle can have many. And in that direction, keep going. So I need to check on the x. Do we have an obstacle in the current range? Or on y, do we have an obstacle in the current range? Well, it depends. If I'm going east to west, so the x would change, but the y doesn't change. So I need to check on the y. Do we have So we need another data structure. So basically now we have a range, right? And then we need to check whether there's a number within this given range. Whether there's a number in this range. How do I check that? If I can sort it, then I can binary search twice. Could be 10 to the 4th. What if the obstacle is at 0, 0? I'm curious. Do we have 0? No. It doesn't affect. It doesn't affect because it's already there. Yeah, this simulation part is easy. What difficult part is how do we check when we need to stop? Especially if you have multiple on a single row, a single column. How do I do that? So you can have a lot of obstacles. Oh, but your integer range is 1 to 9. Huh. 1 to 9. I don't think so. I have to sort every single one of them. Maybe that is the only way. Gosh. Okay. I know Java has sorted list. No, there's no sorted list in Java. I thought there is sorted list in Java. Do we have it? Oh, a tree set. Oh yeah, it does. Java.utility dot sorted list sorted set. Yeah, we don't really need this. I just sort it at the end. Yeah, just sort it at the end. Now I am worried that it's going to time out because well, it time out. Try to do it twice. I shouldn't because we're doing. Yeah, it's not repeated. Okay, it's not repeated. All right, all right, all right. And oh, I don't know. Looks to be very convoluted. Not sure if that is the right way to go with this problem, but let me give it a shot. So we need obstacles. I have to be a map integer list of integer, right? Row obstacles, right? And then we have to do again, and then we could say columns obstacles, and then for int ob of obstacles, right? Row obs dot put if absent obs 0 new array list, almost like a graph. Column obs dot put if absent 1 new array list. Oh, okay. Now row obs dot get yes 0 dot add 1. And this will be 0. right? So we get that, and then for list integer val of row obvious dot get values vals dot sort. Huh. Okay, how about collections dot sort vals? Okay, let's do this again. And we say now this time it's gonna be columns, right? So now we have row and column all sorted. Now we need to simulate. Okay, we need to simulate, and basically what we're going to do is we'll have our directions. Zero, 1. That's 0, 1. I'll go 1, 0. That's fine. 1, 0. Alright, so 1, 0 is going to the right. Then 0, 1 going down. Then minus 1, 0. Then 0. Wait, hold a second. That's 1, 0, 0 minus 1. Right? Because 1, 0. Oh. Yeah, that's okay. I'm going clockwise. Right? 1, 0 is going right. 0, negative 1. Negative 1, 0. And at the end, going up is 0, 1. Okay, so this is east, south, west, north. Yeah, very important. And we need to write a private. So what we want to do is to check if what's the next position, right? Next position. So int get next position. We need a command. Okay, we have direction. We need a command. We need map integer list integer row obs map integer list integer column obs. Right, we have obstacle, and we also need command int I int j. All right, so now I have all this, and I have command. Right. Oh, and direction. dir index, direction index, di. Call it di. Okay. So now I also have di. Right. Private. All right. So now I have di. Then depending on the command, right? If command is equal to -1, which is turn right, okay, turn right, then di equal to di plus 1 mod 4. right? East will be south, south will be west, and west will be this. Else, if, oh, I just realized I need to do this. Command equal to -2. di equal to di -1 plus 4 mod 4. Right? Because you're turning left, which means if we go north, you turn left is go west. From west go south, south go east. And if you're east, which is 0, 0 minus 1 into plus 4. So yeah, we can actually just say this will be plus 3. Can't you just return there? Else it's a distance, right? Then we have to check. Then we get the result. I think I can just return new int ij when basically it didn't change, right? If this return new, oh shoot, the direction changes. All right, let's put. Oh my god, because I'm just getting the next position, but I'm not getting the. Let's put these two. Let's put these three together. Okay, so int position, yeah, position equal to ij direction. Okay. Good. We just return the position. We don't even return anything. Is we make change in place. And basically this is position 2 equal to position 2. We don't do this, right? And this is the same thing, position 2, position 2, don't return anything else. All right, this is position is composed of 3 elements. Okay. All right, next we need to do this. So next I shall equal to position 0 plus di this dot dirs position 2 0. Right, next j 1 position 2 1. Right, so I got next I next j. Then we say if ni equal to I, well, this position 0, right? So this is moving east west. No, north south, because their I is the same, right? So we have this. Now we just have a range. We want to know if an obstacle exists in this, right? So I'll check to see if ni, right, if because we know this, so that's column obstacle, right? That's column obstacle. Wait, hold a second. That's row obstacle and a column. Row obstacles on the row, column obstacles on the column. So the row obstacle, yeah, I think this was wrong. The row obstacle is 1. This should be 0, right? A row obstacle is on a row, so we need to record the y's and put all the x's on it, right? And this shall be 1, this is 0, and this is 0, and this is 1, and also this is not a row, this is a column, right? Column is, you get the x, you get all the y. So okay, so if column obstacle that contains key ni, okay, we do some stuff, and else, right, which means we doesn't have it. If we doesn't have it, then position 1 basically will equal to nj. That's done. All right. Else, if ni is not equal to position, then yeah, nj. So this is moving east, west. Again, if row obstacle that contains key nj, we do some stuff. Wait, hold on. And then we say else position 0, right, shall equal to n is ni. Wait, hold a second. This is nj. This is nj is the same, right? nj is the same, which means you're moving horizontally. No. Yeah, it's row, right? Row, then moving horizontally. Huh? Oh my goodness, this is 0. This is an I. Huh? Ni is equal to, yeah, Ni is equal to moving vertically. So N0 doesn't change. Wait, what's I, what's J? What's I, what's J? IJ is, J is the column, I is the row, right? J is the column, I is the row. So if I is the column, I is the row, it's not X and Y, I is the row. We're using row and column, so I is the row. So if Ni is equal to, so this is the same row number, right? So this is moving east-west. Yeah, this is a row obstacle because I is the same, right? I is the row, J is the column. So I is the same, we're moving east and west. And then we'll check a row if it contains. If a row doesn't contain, then this will be J, right? This will be NJ. And then here is north, south, is when the J is the same, which is your column, which is a column is the same. Then you will set N0 equal to Ni. That is correct. And then we don't change anything. But here, we do need to change because we need to know whether it is in, right? So they have been sorted. So you have the start and end, okay? So position 1 is the start, nj is the end. Okay, nj is the end. So what we want to see is if in this range anything is in this, right? Anything is in this. So what do? We do nj, but positions 1, we do a binary search, so we get somewhere, and nj we do binary search, we get us somewhere, right? We get us somewhere. Now if they match, what do you mean they match? They should not match, right? They shouldn't, because we will never hit, right? We'll never hit the obstacle, so they will never match. So nj, so the original will get a insertion point. Okay, we'll get an insertion point, and the other one will get an insertion point as well. Okay, and then if the two insertion points are equal, that means they do not hit an obstacle. There's nothing in between, right? But if they're not equal, that means there's some obstacle in between. Then which one to pick, right? Which obstacle to pick? Because it's the insertion point, right? So it's the insertion point, and also depends on whether it's going positive or negative. So we'll have to consider. It's always nj. It's always the position 1, the original one, right? Original one. So if it's going to the right, then that value, whatever that value is, right? The index. If it's going to the left, then it's whatever that index minus 1. That will be, yeah. Okay, so basically we have index I shall equal to row, wait, is that collections dot binary search row obs dot get ni, key will be position 1. Right, it shouldn't, unless the starting point be 0, 0. Yeah, the starting point can be 0, 0. So if the starting point is 0, 0, or we just ignore it, right? So if, because you can only fully match, right? If we fully match, we just say if, oh my goodness, so what I'm trying to say is, and how do you know that it is a Gordy? It can only be 0, 0, because if it's the any other position, you will not reach it, right? You will just not reach it, because your binary search, you will find out that it's in your path, and you just don't reach it. So the only possibility is initially that's 0, 0. So if it's 0, 0, well, this, so ni will become 0. Okay. Yeah, we're trying to go to the next position, right? Ni is 0. And then we try to see, we go from 0 to something. And then, well, binary search, one will be matching, right? And the other one, yeah, it will be matching, right? You will match. The destination will match. No, the destination will, yeah, if the destination match, then it's fine. It's fine because we are trying to just see if the two are different, right? So if the start match and a destination also match, yeah, if the start, so basically we shall ignore the start, right? That's the idea. You ignore the start. If you ignore the start and you basically say the end, right? The end, then you will have, oh yeah, you ignore the start, right? You ignore the start. If you ignore the start, if the end hits, then you basically cannot hit it. If the end does not hit, but there's something in between, so the start, you still need to binary search the start, right? So you'll binary search the start. If the start matches, if the start does not match, you will +1. Yeah, you just automatically +1. If the start matches, you +1. Because the start should not match, right? The start shall not match. If the end match, yeah, you just always shift to the right. Yeah, if the end match, you shift to the right, and then, yeah, I know, because if you shift to the right, what are we doing here? What are we doing here? We're trying to see if the range contains from start to end, if there's any obstacle in between. We want to find the obstacle closest to the starting point, right? Close to the starting point. So shouldn't we just do one binary search on the starting point, right? And then we move, yeah, we do the starting point, we do a binary search, and we check where it ends, right? If it's in between, will be negative, so we know in between, and then we know the next one, right? We know the next one, and we can use that to compare, and then we'll know from there. So in that case, yeah, I just need the starting point, right? This is the starting point, so I have the index. Now if it fits, if the starting point fit, then we should ignore it, right? We should ignore it, and we just look for the next one or the previous one, depending on the direction, right? Depending on the direction. Yes. And if the next one if it's in between. So yeah, we consider them separately, right? We can say if index is larger equal to 0, okay? So the starting point is on an obstacle. We can ignore this. We can ignore the obstacle. Right? We ignore the obstacle. But it's row, so we get that position, and then we decide on the direction, right? We decide on the direction, and we say we need to know the next obstacle, right? We need to know the next obstacle. Now it depends, right? Now it depends on the next obstacle. So if position, no, direction. We want to know if direction, this dot direction, position 2, right? And are we going east and west, right? East and west. That will be 0, right? That's your direction. That's the I. No, yeah, but hold on. East and west. Yes. That's east and west, right? Huh? That is not true. That is not true. That is not true because I got this one wrong as well. I was thinking about this is IJ. This is north. Okay? This is north. And 0 minus 1. That's west. South. That's east. North, west, southeast. That's counterclockwise. That is counterclockwise. So if you turn right, that should plus 3. This should be plus 1, all right? If command is -1, you turn right. So if you go north, you turn right, you should go east. So you have the plus 3, yes. If you turn left, north, plus 1, you turn west. Yeah, because 0 minus 1 is going left. We do the column, right? Yeah. Oh, and then we have Ni and J, and this is moving east to west. Okay, so we are doing J, right? J is changing. So yes, this has to be 1. Right, so J is changing. So basically, if this is larger than 0, right? So if this is larger than 0, then we are moving to the right. Right, we're moving to the right. Then what we need to compare is whether so position 1, right, shall equal to index, because index is larger than 0, so index plus 1, right? Index plus 1. If index plus 1 is larger or equal to row obs.getNi.size or row obs.getNi.get index plus 1, right? So either it's bigger or the next index, right? Index plus 1. The next index, which is the obstacle, if that is beyond reach, is larger than nj. It's larger than nj. If that is true, then position 1 will become nj. Otherwise, which means it's smaller than this, right? And it's smaller equal to nj, which means you will hit it. Then your position shall be row obs dot get ni dot get index plus 1 minus 1. That is your position. That's the maximum you can reach, right? And then we'll end right there. Of course, we have an else. Let's go in the other direction, which we can copy and then paste this. So this one will be minus 1 is if it's smaller than 0, right? If it's smaller than 0, which means we don't have anything on the left, or this minus 1 is smaller than nj, right? It's smaller than nj, so you cannot reach it, then we do nj. Otherwise, we'll do minus 1, this should be plus 1. Yeah, so that's the two situations. And then moving north and south, it will be very similar. Oh, wait, hold on, we haven't handled the other. We have an else. All right. So this is starting point is an obstacle. This is the starting point is not on an obstacle. Okay. So the starting point is not on an obstacle. Then it will be pointing to, depends, right? Depends on, so it'll be pointing to the, oh my God. Again, right? Again, we shall say, if this dot dir position 2, 1, if it's larger than 0, so we're going this direction, then position 1 shall equal to something. So now it's index, right? If actually we shall redo this. Index shall equal to minus index plus 1, if I remember correctly. Binary such. Minus is, so it's plus 1 minus. Plus 1. Right? Well, plus 1, then minus. This is the insertion point. So if we're going to the right, then position 1 should be this is larger equal to row ops dot get ni dot size, or row ops get ni dot get index is larger than ni nj, so we do nj. We do nj, otherwise we do row ops dot get ni dot get index minus 1. So these two are very similar, right? These two are very, very similar. I think I can combine them by handling index itself, because this is just index plus 1, right? We just go to the next one. Oh, but this is different. This is why I need index. We can deal with this. Right, we can say if it's larger than 0, we're going to write, then index shall equal to index larger equal to 0. If it is, because we're matching on this, so we move on to the next one, index plus 1. Otherwise, we do this negative index plus 1. Okay, I'll move on to the next one. And then here, we can do, right, this, and then this plus 1 will just be index, and this will just be index, right? Else, we say index shall equal to index is larger equal to 0, then index minus 1, right? Otherwise, it's going to be minus index plus 1 minus 1. Because if it's we're pointing to the opposite direction, if I match, I need to move to the left, right? If I match, whatever I match, but I'm going to the left, so I need to do minus 1. If I don't match, right? If I don't match, then it's going to be the next one, right? To the right. That one will be the matching. That's the insertion point. And I also need to minus 1 to the previous, and to see if, yeah, so I will do that. And this is the same thing, right? If it's smaller than, and then we say smaller than this. If it is, then we shall do this plus 1. So by doing this, I can eliminate this and the 6j. I can eliminate all of these. This the dirs, right? So we do a binary search, and then we handle this, and we will do pretty much the same thing. Right, we'll do pretty much the same thing, but we need to handle it a little bit better. So this, first of all, it's not rows, it's columns. Alright, contain nj, because j is the column, so column doesn't change. And then we need to do binary search on the columns, right, using nj, and that would be position 0. Right, so we have the column, we find the nj, and then we have a bunch of stuff, and then we binary search on the position 0, which is your rows, right? And then this is going to be 0, because the current going north and south, so we go 0, right? So if we go up, right, we go up, then we say it's the same thing. If index is larger equal to 0, then we're matching, then we push on to the next one. Otherwise, we do that. And this is going to be position 0. And this is actually all the row ops. So we're going to change it to column ops, right? So column ops, and or the ni, we need to change to nj. nj, right? So nj.size, if it's larger equal to nj.size, so it's outside, or if we the get index is larger than ni, right? That's larger than ni, then it will get ni, the next index, or we'll do to get the next one, and then we minus 1. That's the position. Or here, it's the same thing with the minus 1, and then we do this, and then we say again to be 0, if it is smaller the column nj and smaller than ni, and this one will be ni, and then this is the nj the index plus 1. Otherwise we do this. Okay, so that is the whole thing, right? And what we're gonna do is go through the commands, right? We can say for int c, right, of commands, and we will have int position, new int. So we start with 0, 0, and going north is 0. Oh shoot. 0, 0, 0, right? So start at 0, 0 and going north. And then here we can just call get next position. We have position, command is just C, row obstacle, column obstacle. Yeah, we just keep doing this, and at the end we'll return position 0 times position 0 plus position 1 times position 1. All right. Let's give this a shot. Let's hope it's correct. We already invest a lot of time in this. I really hope that it can be right, but it's not. This is very, very, very bad. Ridiculously bad. All right, system.out.println arrays.toString. Let's check the position, see what comes out of it. 1, 0, 0. That is bonkers, man. Hey, what do you mean by 1? Did you even add the command? Oh, that is bonkers, man. I forgot the command. Times command. Okay, this one is right. Let's try. Let's try all the others. Ugh. The last one. What happened on the last one? Oh, shoot. Ever gets. Oh my god. Okay, so just a few int res equal to 0. And we'll do this. Res equal to math.maximum res and this. And now we'll return res. Okay, so this is what we get. We call it the full simulation. A74. Full simulation using binary search to check whether the next command will encounter an obstacle, either on the row or column. Well. I think it's O M plus ON plus M log M, where N is commands, M is obstacles. Because you take OM to do this, and then M log M. I think this is M log M. You pick every single one and you do this. But the first one, for each one you need to do a binary search, right? So we can call it ON log M. Oh, let's hope that it's not going to time out or anything. If it will, then that'll be a very sad day. It does not. Okay, it does not. So at least we got it done, but very, very tough. Yeah, very tough to get it. Yeah, full simulation. Do you use a binary search to get this? Command contains max.max. I don't see any. Move forward. Is M times N. M plus N. Huh? Really? Oh. Huh. I'm solving or using a more. There's a step. You just go one by one. You seriously go one by one on the step because there's only 9 steps. I see. Yeah. Okay. Yep. Yeah, it took a while to get this logic right. Because it could be rows, it could be column. How did they handle this? Next x, next y. Has coordinates. Yeah, they just keep moving forward. Wow. Holy crap. Obstacle set. Hash multiplier. Ooh, this is interesting. A hash multiplier. Okay, that's actually I agree. Yeah, this is a better way. Hash multiplier. Or you can just do stringify it, right? You can stringify it. May will take longer, but hash multiplier. Okay, I'm not gonna implement this. This is actually much easier. So just you will walk, 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 and each time you just check. Each time you just check, and then if it contains, you break. If it doesn't contain, you keep going, and then at the end you do this, and then yeah, you get it. Mine is a little bit more complicated. All right, I spent a long time today. I'll see you guys tomorrow. Adios.